Hi everyone, my name is Andrea Njegovan and I am Engineering Manager at Kindred. I welcome you to the first Frontend Meetup Malta of 2021. We have experts in the field here with us today, Rish, a senior front-end developer at Kindred, and Mark, the CEO and founder of Talexio. Please feel free to leave your questions in the comment section and I will read them after each speaker finishes the talk. Now, without further ado, I welcome Rish.
Thank you very much, Andrea. Hey, everyone. Thanks for joining me today. I am Rish, a front-end developer here at Kindred. I work mostly in React and the ecosystem revolving around it. And today, I'm going to talk about scaling your front-end using the micro front-end approach. For today's topic, I'll try to avoid the geeky little details and focus mainly on simplifying the concept. But before we dive in, let's take a few minutes to understand why we need to scale. In a modern web architecture, we have different teams owning the responsibility of the front end and the back end. This gives them the freedom of working independently of each other. For today's topic, however, we are just going to focus on the front end part. Now let's have a look at the CI/CD pipeline of a very simple web app, which has just few lines of code, nothing too complex. There are just 3 devs in the team making the best use of this pipeline, which does not take much to compile, perform regression, and release the app. It's essentially a monolith with a single code base. But with time, our simple application can grow huge and we would end up with a low moving parts to it. And as always, we want to release new features as soon as possible. So we add more devs to the team. However, when team size grows, it becomes incredibly challenging to maintain the consistent design. There might be cases of code duplication where one component is used in several places. A very interesting scaling option that we can think of is to break down the code in different components or packages and put them in a different repo from where they can be installed as a dependency. This solves most of the issues related to maintainability. But on the other hand, it creates something called dependency hell, where each package needs to be updated with the latest version. For example, if package 1 gets updated with a new version and package 2 is using the package 1, then we need to update the version package 2 and so on. This is not ideal. So to solve this issue related to updating the package, we use something called monorepo. With the idea of monorepo, using libraries like Learner, we can have separate NPM packages that could be maintained by different teams and would not have to worry about maintaining the versions. And yes, this seems to work quite well. However, it comes with its own set of challenges. Since these packages are going to be consumed and compiled as a single web app, the code size can get incredibly bulky, eventually leading to longer load time for users. And we don't want that. Also, imagine having 100 devs, each working on their package, trying to merge their changes for deployment. And it could happen often that there are merge conflicts, since monorepo is in the repository. And also blocking of the release pipeline if a test case were to fail. Another possible problem with this setup is the build time. when your application becomes huge, it takes a lot of time to compile it, and due to regression testing on the pipeline, resulting in slower releases. So what can we do about it? Well, introducing micro-frontend. Back when we had just 3 devs in the team, and the app was simple, with just one component, things looked all good, and everyone was working very efficiently, no much conflicts or no blocking of pipelines. So why not try a similar approach and keep things simple? So by dividing the team in a way where they are each responsible for the module from end-to-end delivery. One team is responsible for, let's say, a header app. Another team would take care of the image gallery, and a third team would manage the registration journey of the user. And these micro apps could be combined into one at runtime on production in something called App Shell. This architecture comes with a lot of benefits. In a large organization, it's almost impossible for everyone to have the knowledge about everything. In a smaller group, such as these, the teams would be expert in understanding the business logic of the components and would be free to make their own decisions around it. There is also minimal coordination required between the teams since they are going to work independently. At the same time, they could each choose their own stack or language to write the code as long as in the end it gets compiled to vanilla.js. For example, one team would prefer to write in React and other would prefer to write in Vue.js. Some wants to use TypeScript while other wants to avoid it like the plague. So this architecture gives you a complete flexibility over your stack. Also, time to market is quite fast when releasing new products or features or even fixing a bug. These micro apps can be developed independently, tested independently, and deployed independently. And in worst case, even roll back independently. So you won't have to downgrade the whole application if there was a major bug in production. Here, Team Cat wanted to deploy a new version of the image gallery, but the regression test failed, and hence blocking the pipeline. This, however, did not stop the other teams to release their apps. So Team Alpha went ahead and published their enhanced version of a new registration app, while the image gallery retained its previous version on production. Next is Kindred releases. A small part of app is released to certain demographic users, while keeping the application same. Very useful for A/B testing, and in which way, let's just say we wanted to test just the image gallery. So now that we understand why we need micro-frontend, let's see how we should adopt it. The first thing to identify is how are we going to slice our app. We can go for either horizontal slicing, in which we slice the app in different parts like header or the registration and the image gallery in a single view. Or we could choose vertical slicing, where each path has its own micro app. For a large application, it is always recommended to use vertical slicing to avoid complexity of combining them in one view, and also for better user experience. This is, however, that must align with your project and the team structure, of course. The next step is to bundle and package these micro apps. One of the most popular app library that was made for creating a micro frontend is Single Spark. It comes packed with features that can be used and get you started in no time. Webpack 5 introduced something called Module Federation in its latest version. It has out-of-box support for dynamic imports. However, one might feel a bit restricted because it does not give you much scope of customization. The third option is to use System.js import and vanilla script. System.js is supported by most modern browsers, and we also have awesome polyfills available for it. Just to keep things simple, I have used the last option for my example website. First, we need a micro app. Let's take an example of a header app. It's a very simple component written in React. This app needs to be compiled and bundled in a format called system format. A system format is something similar to what it should look like on the screen. The compiled version of the file should start with system.register. There is something very important to note here, that the common library files such as React and React DOM can be shared among all the micro apps, and we do not want to include them when creating our package. One of the reasons could be to have the same version of the library on all the micro apps. Now that we have our micro app ready, we need a container combining all these apps in one place. Let's call it a shell. To load the micro app, we would need to use system.import function provided by the browser, which would return us the micro app in form of a promise and load the app on the screen. We can make our code a bit cleaner by providing a list of mapping with name and source of all the micro apps that we are going to use in a very nice JSON format. So here we map header to its source, and we could use them inside system.import instead of the complete URL. A challenging part of this micro frontend architecture is the communication between the micro apps. Conceptually, micro apps must be self-contained. However, there are times when we do need to pass data between the apps. An efficient way of doing it could be the browser default dispatch event using the publisher and subscriber model, or an alternative could be using the global shared state. It's up to the team to decide how they want to communicate between the apps. But the only thing to note is don't use the Windows global object for storing the data. So in the end, it's up to you and your team to decide if using micro frontend is the right choice. It's definitely not a silver bullet. And that brings me to the end of my presentation. Hope you enjoyed it. The team at Kindred currently uses this micro frontend architecture to match our user experience model. And we are always on the lookout for enthusiastic individuals to join our team. So feel free to check out our career page and see if something tickles your fancy. Thanks again. Over to you, Andrea.
Thank you very much, Rish. Great talk. We are moving on to our next speaker, and that's Mark. He will be talking about GraphQL. So welcome, Mark. So Mark, we can't hear you.
Can you hear me okay?
Yes.
Thank you, sorry. Thank you, Andrea, for having me. Over the next 15 minutes, I'll be talking about GraphQL. I'll give a brief introduction and we'll do an overview. I will not go into too much detail, but hopefully it can give you an insight as to what GraphQL is all about. My name is Mark. I studied software engineering. I started my career as a front-end developer. I mastered in advanced computer science. I founded Prio Software in 2009. And eventually we created the Talexio product team. Talexio is all about making the best tool for improving organizational health. We have a team of 13 people. We're structured in an agile approach, and we work hard to ensure that we have stable releases and a continually improving product. Front-end development was quite different back when I started, back in 2007. Back then it was more about building websites than building applications. Why? Because there was yet not much of what we now understand as web applications. In fact, Ajax was still quite the hack. There was basically we made use of the XML HTTP request to achieve the effect of Ajax. There was no browser standardization for doing that. So you had a way of doing it on IE, a way of doing it on Firefox. So it was quite interesting, let's say that. There was no such thing as front-end frameworks. jQuery was quite new. We used to use Scriptaculous before that as well. So here I'm talking ancient technology. And people were still discovering MVC. Many people still created their websites using Postback, that relic from .NET. Amazingly, some still do. So this was a very different world for front-end development. Front-end development now is very different, as you all would know. New technology has made it possible to build some great tools. So the concept of rich internet application is now real. Front-end frameworks have made our life so much easier. Even with things like progressive web apps, now we can start building offline web apps. So things are very different. So with better technology, we have increased the complexity of our data structures, which means we have higher expectations from our users. People are used to good experiences when they use web applications. So yes, we are front-end developers. Yes, we're building front-ends, but the API connectivity is very important. How we communicate with our servers actually has a big impact on our applications. A good front-end needs a strong API, yes, that is reliable, well-structured, but also discoverable. Because our ability to talk to the API directly impacts our users. So if we have a bottleneck, which is the API, in our ability to make a good user experience, then we have a problem. So functionality, speed, and yes, user experience are affected significantly by our APIs. To further elaborate a bit on this thought, I like to believe that if the user cannot build a mental model of their journey through the application, they will feel lost and confused. So to give you an example from our product, as a user, when they use the punch clock, online punch clock maybe, to clock in and out of work, they need to understand that they are using the punch clock, that their manager is approving their time, and eventually they're getting paid for their overtime. So this is a model of sorts. Behind the scenes, we know there's a slightly more complex model, a database model going on. But we should not have any constraint in communicating this model to our users and using it as effectively as we can to make the user experience the best it can be. At this stage, it might seem, how is this related to GraphQL? We'll get to it in a second. So GraphQL is a language that allows us to communicate with our API. It was developed by Facebook for internal use in 2012. Around 2015, it was published, but the actual first stable release was in 2018. Yes, people would have started using it before, but the first stable release was in 2018. It's not a special kind of database. When I was studying, I remember we were dealing with graph databases, which were very different. A graph database is a node-based database, so there's no traversal and things like that. This is a graph API, so it's different, not to be confused. There are some other tools that we use along with the idea of GraphQL. In our case, we use Apollo server and client. Apollo is a company that provides a platform for using GraphQL. So you can think of these as packages, node packages that you can use. The Apollo client makes GraphQL, yes, easier to use. So there are others, I believe, but Apollo is very, very stable and very reliable in that sense. For the server, we have the Apollo Server Express, which plugs into Node.js. I'm talking about Node.js here. And for the client, there's just Apollo, which is the Apollo client. Why consider GraphQL? GraphQL gives us more control of our application performance. Instead of sacrificing control of our application, we have full control of it now. No one will tell us what we can and cannot do with our front end. So basically, and that down there, that's a small screenshot from the GraphQL website. GraphQL allows us to describe our data. Yes, this is probably being done by the API developer. But more importantly for us, we get to ask for what we want, and we get to receive that which we asked for. This will reduce the implementation issues and will give us a better understanding of our own data model as well. I'll get to more detail about how this is achieved. At Talexio, we have a full stack TypeScript. So we've built our front end with TypeScript, and we've built our API also with TypeScript. This gives us a bit of an advantage in being fast to develop and being full stack developers as well. But the reason I'm showing you this is so that you can see where GraphQL fits in this architecture. So in the front end, yes, we use Material UI. Hopefully, we'll be getting a new version soon, according to Google, some recent news. We built that on top of React with TypeScript. In the front end, we have a lot of GraphQL queries, which are talking to our Node.js server, which is Express.js. There's type ORM to talk to the database and ORM, and then there's the database. Of course, all of this is on an infrastructure, cloud infrastructure on Amazon, which is scalable, etc., etc. So all this is stateless, but I will not go into those architectural details. What we care about at this stage is the bit over here, which is the GraphQL part of this equation. First off, I wanted to compare a bit GraphQL to other types of APIs that we could be using. Of course, I guess maybe not everyone on the call, but SOAP was a thing, right? It's very popular actually. I mean, it was very widespread. SOAP was very structured, highly structured. So you have all these envelopes and all these WSDL definitions of your API. It was most definitely not lightweight. So there was a lot of overhead in order to make a request. In order to talk to the API, you needed to send an envelope which is huge, which has headers, which has food. It was quite bulky in that way. This I'm not sure about this, but maybe it's not so popular anymore. I hope. Then there's RESTful. Many people misuse the word REST when they don't really mean REST, they just mean a JSON-based API. So RESTful has actually there's a standard that tells us how we should structure our endpoints, how many. So for example, for every entity, you must have a unique URL for it. So there is structure, so it's high on structure RESTful API. Discoverability can be achieved with some things that were added later to the standard. Or also things like Swagger and things like that. Yes, it is lightweight, so you could have your request. They're just JSON, no extra headers, or just a bit of headers. And the usage is very widespread, of course. I guess what is more widespread is the JSON-based APIs, where someone just builds their own API, keeps it simple, just does what it needs to do. You have some endpoints doing the things they do. This can grow, though. This can become quite huge, actually. The RESTful the standard is good because it's, for example, if you're working with the Internet of Things, if you're creating an API on your devices, then you know that every device has its own URL, for example. There's a unique identifier for everything in a RESTful API. Whereas JSON-based API, then it's up to you to do what you want, and maybe someone won't support your API. And then there's GraphQL. GraphQL has inbuilt ways of being discovered, of a front end to find an API and to use it. Yes, it has structure as well. Hopefully not as much as SOAP, but there is structure, which is useful. It is also lightweight. I'll explain how it is lightweight. I think usage is growing. It's quite trending in this regard. The biggest benefit of GraphQL is the flexibility for the front-end developer. So how does GraphQL work? And this will sort of tell us how it's different. In GraphQL, in most cases, we only have one endpoint. That's already something a bit radical compared to RESTful, where you have an endpoint for each. We have an endpoint for users, an endpoint for invoices, whatever. But in GraphQL, you only have one endpoint. There is a schema available that describes our API. The schema tells us what can be queried. Those are queries. What data is returned, and what can be actioned. What can I do in this API? Yes, as we said before, the API consumer, which is the application or the front-end developer, gets to decide what data they need. So knowing what we can query, we can build our queries in the front end. All queries are sent to the same endpoint, and the API will respond with just the data that was requested. So here's an example. On the left, I have an example of a REST API. Yes, maybe I'm exaggerating in how I'm highlighting the flaws, I guess. So let's say you wanted a list of users and any emergency contacts that they may have. All right, so you want this one query that gives you the list of users and all their emergency contacts. This is actually something that we have in our product, where you can get the emergency contacts of an employee. If you're building a good RESTful API or a REST-ish API, a bit RESTful but not completely, you will probably have an endpoint that is users .json or .xml, whatever. That gives you a list of users. The front end will make this call, and it will receive the list of users. It wouldn't make sense to include all the emergency contacts as part of the user's request. Why? Because in many cases, you want to get the users without the emergency contacts. So it actually makes sense to make this just give you the users. In our case, though, we want to show the emergency contacts. So for every user, we are going to query the emergency contacts of that user. So here we have n+1 queries, where n is the number of users. So when we study algorithms, we know that anything that has n in it is probably going to be slow. Alternatively, yes, we have another solution. We could call the API developer and say, hey, I need an endpoint that gives me exactly what I need. So now it's one query, but there's also a request to the API developer, and probably that API developer also needs to update the API documentation. You can see how when you have a big project, this can become quite huge. You have hundreds of endpoints in a REST API because people are asking for new things, and unless you sacrifice performance, you're going to end up with a big API, with a huge API. On the right-hand side, we have an example of a GraphQL query. So this is crafted in the front end. The developer says, OK, I need a list of users. From every user, I just need the first name and the last name. So forget all the other fields. I don't need them at this stage. Maybe I need the ID. And then I want the list of emergency contacts for every user. Their first name, their last name, and the contact number. That is what I will use. Run this query, and GraphQL will give me that information. So there's a stark difference between one query and n+1 queries, or n plus a lot of hassle. Sorry, one and a lot of hassle. So that's the querying bit. As you know, as front-end developers, you may want your application to load as fast as it can. Our users are used to mobile apps. On a mobile app, they have offline data. Everything I'm saying here applies for mobile apps as well, by the way. So there are caching policies available that a front-end developer, it's at the discretion of the front-end developer to pick a caching policy, a fetch policy. There's more than these, actually. But for the sake of brevity, I'm going to focus on these. So one of them is cache first. So cache first is if everything in the query is available in the browser already or in the application already, just get it from there. Do not go to the API. So that's a cache first strategy. So in our query example, if we had this query, if we already got this information, it would just serve it immediately to the user. Click offline, so no web request, and the user gets their data. Super efficient, but maybe not ideal because the data will be old. Then there's cache only, again. By the way, if it's not available, then it would go to the API in the first one, right? And then there's cache and network, which is the one I like most. This one will load the data from the cache, so the user has a super snappy experience. They get what they want. But a few seconds afterwards, or milliseconds, hopefully, it will show the updated data because behind the scenes there was a request. Now, in most cases, maybe this doesn't change. The user is unaware that there was an update. But it works pretty well that way. So you launch both queries automatically behind the scenes, one of them querying the cache and one of them querying the network. The end user will have the best experience in this case because they got the data fast. Most cases, they will just click it and proceed. But you also know that you're giving them up-to-date information. In all of these, especially in the top ones, you may need to do some manual updating of the cache. So I opened my application, I got the list of users, and I click that button that deletes a user or that changes a user. If I do a query later, I will get the old data because the cache has the old data. So I will need to manually update the cache. There are ways to do this, especially Apollo provides nice mechanisms to do this. It's not as complicated as it may sound. But it's good that when you do a change, an action, that you update your cache. Here's an example of a mutation. So a mutation is an action that you want to do. So it's not just querying, but you want to tell the API to do something. An example for us from our system is submitting a leave request. So when an employee says, I want to book leave, this is being executed behind the scenes. Our request is called save employee leave. This is written in the front end on the left. So on the left is what we have in the front end. Okay. Even on the right, sorry, is what we have on the front. And this is the query definition. So what we are sending to the API, I'm calling the save employee leave mutation. I'm giving it an input. And I expect as a response to receive an employee leave record. And again, I can customize what I want to receive, because many things maybe I don't need. And this will make my querying faster. There's a refetch queries option that allows you to automatically refetch so that you refresh your cache as well. The get request, it does it again. This may not be ideal because actually it might become a bit slow if every time you modify an employee, you refetch employees. Maybe not ideal. So it's better if I update the cache manually. But the key takeaway from this is that when I run a mutation, I can even select what I want in the response. All right. So this is, again, very different from what we're used to in REST. The schema. The schema is usually published by the API. So the API developer would have built this. It is discoverable by frontend via a thing called introspection. Basically, you just send a query and you say, I want to see the schema, and it will give you the schema back based on some settings in the API. But yes, it can give you the schema. So when you discover the schema, you can understand what you can do. This is an example of a schema, what it could look like, all right? There's one endpoint, as we know, which is this one, from here to here, and I can ask for a query, and I can pass these, for example. This is all TypeScript syntax. Things like exclamation mark means required, so there will always be an array returned when you ask for banks, and an array made of bank type. On the right, we have the types. I just love TypeScript. Before, in the past, obviously, we couldn't dream of doing this with JavaScript. So that's the schema. Some other considerations. GraphQL does not dictate how we do our authentication. It does not tell us what we can and what we cannot do in terms of authentication. So we would use our typical methods of whether it's Java Web Tokens or other headers that we want. For example, we do a login action, we receive a token back, we store that token, and we use it with every request. No impact whatsoever from GraphQL being in place. Something interesting is, we actually don't use this yet, but it's actually interesting that it's available off the shelf, is that you can use subscriptions inbuilt. So Node.js developers, even other developers, would be familiar with WebSockets. GraphQL has an inbuilt way to switch on subscriptions. So a user, especially in a chat app, for example, they would subscribe, the front end subscribes to the chat room, and the API will notify us when there's a change to the data. So you shouldn't overuse this, because performance-wise, if you're not sending small chunks of data, it's quite expensive. Something interesting as well that we get from GraphQL is performance reporting inbuilt. Unfortunately, some of the features require a license, because Apollo is not, yes, they have open source products, but it is a private company, I guess. And here, to be fair, they're giving us a cloud-based platform to see these metrics. But it's basically just switching on some environment variables in your application. Then you go in Apollo Studio and you will find your performance insights over there. There are some developer tools that are available, many developer tools. First off, when you run your Apollo server, your GraphQL API, you have an inbuilt API explorer. You may be familiar with things like Postman or things like, I don't know, there are many API explorers available. But here you can create your query and you can test it against the API with this interface. So you don't need to put it in your front end, but you can test and see what you're going to get in the response. That is automatically available when you launch your local environment as well. There are obviously VS Code extensions for everything we do nowadays. There's no doubt that you will find whatever you need there. It comes with its own command line tool, whether you want to build the schema on the front end, things like when you're using TypeScript, ideally you have all the classes that are available to the API, the different types available in the front end. So you use a command, and there's also NPM packages to do this automatically, to build the entities in the front end based on the schema of the API. So it would go fetch the schema and build the local types, so you can use them in your front end. And we mentioned Apollo Studio. In the next slide, I'll get a bit into more detail of what we can see in Apollo Studio. So Apollo Studio is good because it tells us about the performance of our application, of our queries. All right. It tells us whether there are any errors going on with the queries. And there's also something called schema checks. You have an evolving application. Eventually, you will need to change your schema. You will need to add things to your schema. But since we're dealing with front-end applications, maybe the user has the application on offline right now, right? They're not, it depends how good your progressive web app is. But maybe they have old React code in their browser, right? They had downloaded it a year ago. Somehow they never closed this tab, and they're still using that front-end code. So you can imagine how an old query in the front end might crash the application. Apollo Studio gives you a way to test your schema changes. So it checks against the previous schema to check whether your changes will break the front-end experience. Performance is what I feel is the biggest benefit of Apollo Studio. The P95 service time is the 95th percentile of your queries are taking that much time to complete. 589 milliseconds in this case, as an example. So we know that the import courses mutation is taking 21 seconds. That's very bad. That is something that needs to be fixed. There are other queries over there, and it tells us a bit what to look for and what to optimize. Now, this could be either the front-end developer's fault. We wrote a needlessly heavy query, or it could be something that the API needs to fix as well. Especially if it's a mutation, maybe we don't have that much control of what happens behind the scenes. But with this insight, we can, yes, we know that there are uploads fast thanks to Lighthouse and analytics and things like that. But actually, we want to know how long the user is waiting to get the list of courses in that case or whatever. We get the request rate per minute. So there's quite some interesting insights in here. So yes, even if it's just for a month or so, it's good to get that license and try it out because you get some interesting insights about your application. There are many useful resources. This is not something, when something is as popular as GraphQL is right now, that's great because we get loads of resources, loads of packages that we can use. I just dropped some links here, so they're available for you. I'm sure you will not have any problem with finding in-depth tutorials about how to use GraphQL and Apollo. On my part, now I guess we can pass for some questions.
Yes, thank you, Mark. I truly enjoyed the presentation. So are there any disadvantages with using GraphQL?
The first, can you hear me okay?
Yes.
Okay. The first clear disadvantage, I would say, is that there's a learning curve. So even when we search for developers, it's still people are more accustomed to REST APIs. Even third-party tools are more accustomed to REST APIs. So there is a disadvantage there. It's not the most common type of API, and maybe if you're building an API to be consumed by other software, maybe you want to also build a REST API alongside it. But to optimize the experience of your app, of your application, I highly recommend using GraphQL.
Okay, thanks. So we have another question from Rasmus. He says, hi, Mark. How have you solved authentication in your GraphQL setup? If different types of query combinations need different types of authentication, how is that solved?
Authentication?
Yes.
Okay.
So if different type, okay.
We handle authentication with headers. So we have JWT tokens. We have a few endpoints that may not require. So first off, something interesting is we inject handlers into our into the request. So in Express, you may be familiar that you can inject different middleware into the request. So before it does something, it loads some middlewares. So yes, we have some routes that use one middleware and not the other. And the middleware, one of them is, I think it's called inject context, and it takes care of setting up the context of the logged in user. We have cases where we don't have a logged in user. Maybe it's a public link. Maybe it's we have, for example, attendance sheets where a tutor who is external to the system can click a link from their email and submit the attendance sheet. So I believe that's how we solve it. So we have different middlewares available, and we inject based on the routes, and we have an internal structure of how we organize those routes. So we have some routes which are guest routes. We have some routes which are client routes. So that's how we handle it. But behind the scenes, everything, there's JWT web tokens, and that's how we do the authentication. I hope that answers the question.
Yeah, and so thanks. Hope Erasmus did as well. So that would be it. No more questions for you, Mark. Thanks a lot.
Thank you.
See you. Bye. Now, I promised to read questions after each speaker finishes the talk, but I skipped Rish since the questions came late. I guess people needed some time to think about and make sure that you won't cover in your speech later on. So Rish, if you don't mind coming back, thank you. Okay, the first question for you. So it's from another Mark. How is site performance affected, namely initial page load times? So if in the application, 3 different teams opt to use 3 different front-end frameworks?
Yeah, that's a very interesting question, in fact. So micro frontends are technologically agnostic by design. And when you have micro apps in different languages, it would obviously have to load the libraries required for it. But the thing to know here is just because it's possible does not mean it's always a good idea to do it. An ideal scenario that comes to my mind when you need such an approach is, let's say you have the app built in Angular and you want to move all the components to React. So you can do it in parts, creating one micro frontend, and at the same time in new framework until you have migrated to a new framework. So yeah, you can obviously take precautions to optimize the loading of libraries to ensure we load the libraries. Sorry. Can you hear me, Andrea?
Yes, I can hear you.
Sorry. Yeah, so you can obviously take precautions to optimize the loading of libraries to ensure that we load the, let's say, React only when we load the micro app consuming it. And so you can bail out from the initial page load time. Yeah, hope that answers the question.
Yeah, thanks, Rish. Another question from Sheldon. He says, hello, Rish, very interesting talk. It sounded like different teams could use different libraries. For example, React, Vue on their micro apps. Are there any consideration when using multiple libraries?
Yeah, it's almost like the previous question. So you can use the advantage of having multiple libraries, but the precaution that you could take is you load the library only when the micro app consuming it loads. In that way, you can avoid loading the extra libraries and decrease the initial page load time. Hope that clarifies.
Thanks, Rish. Yeah, that's all. Thank you very much.
Thanks very much, Andrea. Have a nice evening.
You too. Yeah, and in the meantime, there is one more question came for Mark. I don't know if he's still with us.
Yes, sure.
Yes, perfect. So Sheldon as well, he's asking, hello, Mark, enjoy the presentation. How do you think the learning curve is with GraphQL? A lot of common concept to other technology or quite unique?
Personally, I felt it was quite unique. But I think the uniqueness came because we were also new to TypeScript when we decided to go for it. So I think most of the uniqueness is coming from there. It was a very interesting journey, though. Yes, you need a you need to watch some good tutorials, and you need you need to get used to for the beginning. Not, I don't know. You think you're going to build a CRUD and it's super easy. You're going to do it really fast, but actually you need to slow down for a sec to think a bit about it, and so that's slightly different in that way. Luckily, there's a lot of resources available, and I would say it's a steeper learning curve than usual. But obviously, as always, it's part of if you're going to be a front-end developer today, you need to be ready to constantly learn new things, and that's what makes our job so interesting. So.
Yeah, indeed, I agree. Thanks. So we have also from Ed, he said, thank you, Mark. And then he continues something on Maltese, which I unfortunately can't read, but okay. You can check it out later on.
Okay, I will check it out later. Hello, Ed.
Yeah, so yeah, that's it. No more questions. Yeah, and time is almost up. So thanks, guys, again. I truly enjoyed both presentations. Great talks. And thank you, everyone, for joining. So this is just one of the series of meetups that will be organized this year. This webinar was online due to the pandemic, but hopefully for the next we can meet in Kindred office or some other location. And then please keep an eye on the Frontend Malta Facebook page and also YouTube channel so you don't miss it. And yeah, have a nice evening, and I hope to see you soon. Bye.